Assalamualaikum and hi everyone. So today our group will be presenting about image processing project, which is insect classification using image processing. So our group is group number 2 and we are from class CS23004A. So let's begin our presentation. So before we start, let me introduce myself and my group members, which is the first group members is Muhammad Faizal, and then Alif Shazwan, Imran Azni, Danish Imran, and Yash Koyomi. So let's begin our presentation.
Image classification is a critical task in biodiversity monitoring, agriculture, and disease control. Traditionally, identifying species requires expert entomologists and significant amount of time. With the rise of digital imaging, automated insect classification with using image processing and artificial intelligence offers a scalable and efficient alternative. So, manual identifying insects, such as distinguishing a butterfly from a bee, is prone to human error and efficiency. This project addresses the challenges of creating a system that can see and quantify the physical differences between insect species using digital descriptors. The goal is to distinguish between species, such as butterfly, bees, or other animals, using digital fingerprints, using MATLAB for high-fidelity feature extraction. Why image processing? Computer vision captures textures and shapes, eccentricity, edge density, and so on, that human might miss. It is also efficient for instantaneous classification for a large data set.
So for pre-processing technique, first, we enhance the contrast using stretching and intensity adjustments. This helps expand the useful range of pixel values so the image become clearer, especially if the original image is too dark or too bright. Next, we convert from RGB to SSV color space for the enhanced image that we have done before. This used because it can separate the brightness information from the color components. After that, we apply adaptive histogram equalizations to the V channels. This step increase local contrast and bring out hidden details. After enhancements, we use croppings so that we can focus on only the important regions and remove unnecessary backgrounds. Then, the cropped image we resize to 2 to 4 times 2 to 4, so every image has the same input size, which is square. This important because for consistent processings. Finally, the resized image is normalized to keep pixel value within the range 0 ones. Lastly, we use output file so that the image can be stored into the files. At the right side, you can see before pre-processing and after pre-processing.
Assalamualaikum, I'm Muhammad Imran bin Azni and I will be explaining about feature extraction. It is the process of converting raw image data into meaningful numerical features such as texture, shape, and color. By doing this, we reduce data complexity while improving the efficiency and performance of image classification. In this research, we applied three features extraction methods, which is first the gray level occurrence matrix or GLCM, second is shape features, and third is color histograms. These methods help identify and differentiate key visual characteristics of both insects. Here are the results. First is contrast histogram. It shows that butterflies have higher contrast because of the stronger variation between light and dark pattern on the body. Second is homogeneity histogram that indicates butterflies have higher consistency of color pattern. Third, the energy histogram tells us that butterflies have more uniform pattern. Next, both insects have similar value of correlation because of the neighboring pixels in both images are similar. Now for the second part, we have area, perimeter, and eccentricity histogram. The area and perimeter for butterflies are higher because butterflies have bigger wings compared to bees. The eccentricity value of bees is higher because of their long body shape. Lastly, the color histogram representing yellow or green color. Bees have higher value indicating that the main color of bees are yellow.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Dinish Imran bin Wan Muhammad Hafiz. So today I will present about the classification process that has been used in our group project. So classification is the automated process of categorizing an image into a specific group. So in this case, our group are using bee and butterfly for our mini project. So bee and butterfly, we are comparing its mathematical features against a pre-trained model. So it will act as a decision-making system where the computer analyze the input like the color and the shape and assign the most likely label based on what it learned during the training phase. So let's begin. So we are going to go through our MATLAB code. So first of all, let's go to the feature extraction. So where is the classification part in this feature extraction? So the classification process is handled by two main scripts. One of the building model and one for applying the new data. So for in the feature extraction, the location is on the line 66 and 67. 64, my bad, 64 until 67. So the code is RF model 3 bagger 50 action villain. So as we can see here, the explanation of this line is this part initialize a random forest consisting of 50 decision trees. It used to extract the features in the extract function and they are non-labeled as a Y train to learn the difference between the insect uh, that we have been trained. So in the testing phase, we are also in the line 33 and line 34. So here, the function applies the train model to the new image features vector since the output is text based in a cell array. So the function of the str2 double is to convert it into the numeric level for number 1 or number 2 something for our final processing. So let's go for the testing phase. So let demo here. So we will test B1. So what is test B1? Test B1 is a B. So let we see the result. So when I run this section, yeah, so the prediction is a B. So the prediction is accurate. So let's change our test image. So let me change it to the test butterfly because we are using butterfly, right? So test butterfly 1. So if we are run and then yeah, so it will show the prediction is correct with the butterfly. So in the slide I have been attached here. So this is our output. So I will pass to Alif Shazwan for explaining the result.
My name is Muhammad Ali Shazwan bin Mustaqim, and today I will discuss the outcome that we obtained from our project. This is the summary after we done the testing in the classification process. For each insect classes, we tested 5 different images, and for the butterfly class, our model successfully identified all the butterfly images that we obtained from the internet. The highest certainty is 94.0%, with it being the butterfly 1 images, and the lowest certainty is 56.0% for the butterfly 5 images, and the average certainty for the butterfly class is 81.2%. However, for the B class, one image was unsuccessfully identified by our model. For the B5 images, our model was misidentified it as a butterfly with the 66.0% certainty. This means that our decision tree were divided into two opinions. One side guess it as a butterfly, however, on one side guess it as a bee. But the majority of the trees decided it as a butterfly, and the highest certainty in this class is 80%, being the B3 images, and the average certainty for the B class is 72.0%, and our model accuracy is 90% with one images, which is B5 images, was misidentified by our model, and the average certainty for our model is 76.6%. This is a good measure our model uh, because our model only train 20 image in total. So our model can successfully identify the each insect classes with over 90% accuracy. This is the references that we use in our project. That's all from us. Thank you. And Rachel Casson once says, the smallest creatures often hold the key to the grandest mysteries of our ecosystem.